What's up guys, welcome back to Wacky Engineering, and today we are going to show you how you can power a 3-phase motor with your residential power grid.
Alright guys, so this is what we're looking at. This is a large industrial squirrel cage fan. This actually came off of a dust collector setup. For people that were doing deburr, it would pull the dust off of their parts. This is the 3-phase motor. This motor can be run on 460 volts or 230 volts 3-phase. Right now we have it wired up to run on the 230 volts 3-phase. So we have 2 belt pulleys on this setup. We're only using 1 belt because it didn't require more than that. There was no slippage. The motor has to spin 4 times for every time the fan pulley spins. So basically this motor is geared down. So you might be wondering, how are we powering this 3-phase motor off of our residential power grid? Let's come on back around and we'll check it out. So the key piece of this build is this piece of hardware right here. This is called a variable frequency drive. So basically the way this unit works is it takes in 220 volt single phase power, it converts it to DC, and then it chops that DC into a simulated AC sine wave, and then it goes 3 phases off of that. That DC bus that it converts into feeds into the SCR packs, and then those sets simulate your AC voltage across all 3 phases. So an interesting fact about AC motors, whether it be a single phase motor or a 3-phase motor, is that they run on 60 hertz, and the hertz is what dictates the speed on them. So if you want to change the speed of a motor, really the only way to do it is with a variable frequency drive, because this unit here changes the frequency that goes to the motor, and in turn that changes the speed of the motor. So if we'd used a DC motor in this setup, you can change the speed of a DC motor just by changing the voltage to it. But in this case, we're going to be running this thing constantly. An AC motor makes the most sense, and that is why we have to have this unit. And the nice thing about this whole setup is you could install this on an air compressor that you got from an industrial factory, a drill press, a large fan like this. Basically anything that would come with a 3-phase motor, that would be what you would want this setup to be installed on. Okay, so let's take a look inside the control cabinet for this fan. So one thing you'll notice right off the bat is we do have a timer, and this timer is used to where when we hit the start button on this unit, this drive will kick on and it will start powering this motor. And then when it hits whatever the preset time is, which I can change just by doing that, it will kick this off. So if you go to the store and you leave this fan on, it will shut itself off after a predetermined amount of time. Right here, this is our input power coming into this control cabinet. This is regular 220 to 240 volts that you would have at your home. Your dryer normally runs off of that power source. A lot of different air compressors in your residential home would run on that power source too. So that's all we have coming into here. We have a circuit breaker, and then we split off power to the drive, which runs on 220. This timer can run on 120 or 240, but we have it wired up on 120 right now. And then we have a control relay to create a latching circuit. This is also the drive manual, and this kind of gives you an overview of how to program some of the parameters in it that control how fast it ramps up the speed, what the maximum speed you would want it to go off of. This also sets up how you want to control it, whether you want just one button to start it, or maybe you want a whole different set of things to turn this on and off. But this manual here would kind of walk you through how to set up some of the parameters in it to control this drive. If you guys want a more detailed look at the wiring of this circuit, check out the schematic now. We also have an hour meter wired up right here, and this meter only increments when the fan is actually running. So that's about how many hours we've ran it, so almost a full day. So right here we have our push button station. This is the start button, and this is the stop button. This is a normally closed push button, and this is a normally open push button. So if I were to poke this button right now, this fan will start up. And as you notice, it is slowly increasing the speed. That's one of the parameters set up in this drive, that it ramps up across a certain amount of time. And hopefully the audio can pick this up, but you hear the whining noise that's coming from that motor. That is a very normal sound that comes from any motor controlled by a variable frequency drive. And if you hop around back here, we can look at the display of the drive. Right now it's displaying how much current that motor is pulling. Right now, the motor is pulling 3.1 amps from this drive. So before we were displaying the amount of amps that the motor is drawing, right now we are displaying the RPM of the motor. And as you can see, if we turn this little pot here, we're able to increase the speed of the motor. Right now we're displaying the amount of load that is on the motor compared to what its full output could be. So it's at about 50% load here. As you see, as we turn it up, now we're at about 88%. So 60% once it normalizes. Anytime you increase the speed, it's going to take a little bit more power to get it up to that speed. And then as it maintains that speed, that load will come down a little bit. Just like when you're accelerating a car, it takes a little bit more to accelerate it, but then once you hit the cruise control on, it takes a lot less to just maintain that speed. So at this speed, it's taking about 65% of the motor's power to turn this fan.
All right, guys, that concludes today's video for this 3-phase powered fan. Hopefully you guys learned something and found today's content interesting. Be sure to like, subscribe, and comment. See you next time.